Good morning, good afternoon, good evening, and good night. My name is William Gathright. I'm the CIO of Fortress Power, and today we're going to take an overview tour of the Keystone Designer system and the Keystone EMS. And we're going to start really at the very beginning. So we're going to start at the very basics, kind of, what is the purpose of EMS? What is it going to do for you in your facility? How do you evaluate some of these things? And we're going to build that up to how do you pick an EMS? How do you design an energy storage system for the commercial and industrial projects that you're doing? And then finally in operations, what that's going to look like. So we tried to take a pretty comprehensive view today. So if there's something I'm talking about and I'm kind of going on about this stuff, it's in too much detail or it's too simple for you, feel free to skip ahead. There's kind of more interesting things ahead, but I wanted to try to make this for as wide an audience as possible. Okay. So without further ado, let's get started. The first thing we'll talk about are the bare basics concepts on how to think about EMS and what is the role of EMS. And I'm going to start very simple here, and I'm just going to take a quick detour into sort of the two terms that we're going to throw around here, power and energy. So for some of you folks, this might be very basic. Again, feel free to skip ahead. But if we think about energy, energy is the ability to do something useful, and power is a rate. Power is how quickly you use energy. And to design a battery system, we have to think about both of these things because they're both important and they do, they perform different jobs in a battery storage system. So let's look at a quick example that I like to go over. We're going to compare a Snickers bar to a stick of dynamite. Right? Now, many people are surprised to learn that the Snickers bar actually has more energy than the stick of dynamite, right? Energy is calories are a measure of energy that many of us are all too familiar with, right? A Snickers bar actually has 280 calories, whereas a stick of dynamite only has 238 calories of energy. But of course, the dynamite is more powerful. It can use that energy more quickly. Some of us, we eat the Snickers bar, we never release all that energy, whereas the dynamite can release all of its energy instantaneously. That's how you get an explosion, right? If you want another analogy here, think about your car. Your power is the size of your engine. Engines are even rated in horsepower, right? Bigger engine burns gas more quickly, right? So the energy is the gas in the tank. You could, in theory, imagine increasing the size of the gas tank of your car without increasing your engine power at all, right? You can sometimes kind of move these things independently and they would do different things. A bigger gas tank would let you go further, and a bigger, more powerful engine would let you accelerate faster, again, burn that gas more quickly. Okay. So let's bring this back to the energy storage world, right? In very simple terms, if we think about energy storage as the battery system, it's rated in kilowatt hours. That's energy, right? So that's a measure of energy. That's sort of like the gas in your tank. And if we want to think about power, that's the inverter, right? Rated in kilowatts, right? That's how a bigger inverter in general can use the energy in the batteries more quickly. So with those basic concepts under our belt, let's look at an example application of an energy management system, of a control system here, right? So what is EMS, just to get some terminology down, right? This is a high-level control system of your entire battery storage system, right? And sometimes even your entire microgrid. So we'll get into more details on that in just a second. But really, if you just think of it as sort of the operating system for your energy storage, that's a pretty good mental model, right? It'll do things like tell the batteries when to charge and discharge to get different benefits. And one such benefit that's pretty easy to understand is time of use, right? If you are charged different amounts for using energy at different times, let's say during the day is more expensive than at night, then a very simple setup for your battery storage system would just be to do exactly that. Use more energy at night, charge your batteries, and then use less energy during the day, discharge your batteries. Right? This is pretty easy to imagine, pretty easy to set up. A more sophisticated kind of application of this is like peak demand shaping, right? So here's where that difference between power and energy really matters. That's why I started there, because this is a power application. Right? Some commercial buildings are charged much differently for their peak power than for just energy used the rest of the month. The utility company will look back over a month, find the 15 or sometimes 30 minutes where the building used the most power, and then charge thousands of times more for the energy used at that time than the energy used the rest of the month. This is typically dollars per peak kilowatt, sometimes 10, sometimes 20, sometimes $30 per peak kilowatt, right? It's almost as expensive as running your entire building on AA batteries for 15 minutes. So it's very pricey. So if you have an EMS and you can sense or predict when the building is going to be using the most power, right? Setting that high water mark, right? Any power above this threshold, you could discharge your batteries back down to this threshold. Similarly, when the building's not using much power, it's below it, you can charge your batteries back up with that cheap energy, and you can safely charge it sort of, until the building is using power up at this threshold, right? Now, like when we go to look at some of the math behind what the EMS is doing, this is what it's thinking about, right? It's thinking about, okay, what is if you are, sitting here, right, on hour 40, you have to make some prediction about the future. How much power are you going to be using minute by minute throughout the next day here, right? Because this is a little bit of a guessing game. If you set this threshold too high and you don't use all the power of your inverter, or you don't use all the energy in your battery, you've left money on the table because you've let the utility charge you for a threshold up here when you could have only been charged for a threshold down here. Worse, if you set the threshold too low, you might run out of energy first, right? You might run out of gas in the tank, of energy in your batteries, at which point you would stop discharging, and your utility meter would read something very high, and now you've set your demand charge for the whole month at this high level. You're going to get hit with a high bill, right? So again, this is one of those funny problems where it's very easy to look back at the end of a month and say, oh, I should have charged here and discharged here, right? It's a little like picking stocks. It's easy to look backwards and say when you should have bought and sold a stock. It's very hard when you're going forward, right? And that's kind of what we're going to do, right? There's a famous quote that predictions are hard, particularly about the future. So that's really the job of the Keystone Designer, to do that math, to do those predictions, to help plan out your system, and then of the Keystone EMS to carry out those commands. Okay? So that's what we're going to look at in the next section here. We'll give an overview of the Keystone EMS and the Keystone Designer system, and we'll start with the Keystone Designer because this is where you will start in your sales process, in the project life cycle, right? So we understand what an EMS is doing, right? Because we understand the difference between power and energy. So we know that we're trying to design an energy storage system that has the right amount of power and the right amount of energy to do our applications, such as time of use and such as peak demand shaving, right? Now, that's not all that your EMS can do, though. So the Keystone EMS is really a fully featured microgrid controller. And this is a word that means different things to different people. Here, let's just consider a microgrid to be any system that can isolate itself from the main electric grid when needed and provide its own power. That's a very expansive definition. I understand that, but I think it's helpful just for this discussion, right? So this can be anything that you have on site that produces power, not just, let's say, a Fortress battery system, but solar power, gas generators, and if you have something more exotic like a wind turbine or some kind of microturbine or a CHP, combined heat and power system, right? Everything has to work together nicely. Everything has to play nicely together to make sure that you can disconnect yourself from the grid in the case of an emergency, and then black start, right? Come up from darkness, from no power to power in a way that no two systems are fighting, right? By fighting, I mean if you try to turn on, let's say, a gas generator and something else that is trying to also produce power, then if they're incompatible, if you do it in a way that is incompatible, right? They're both sort of grid forming, then there's going to be a problem. One of them is going to go back down. Okay. So in order to get an entire microgrid system like that, it takes a lot of planning. And a very important part of that step is going to be the financial and operational planning that you can do with Keystone Designer. So Keystone Designer is a software program that will make financial predictions, operational predictions, and modeling of how a system would work in operation, right? And this is important because it lets you optimize for the amount of power that you should have in your battery storage and other energy resources, and also the amount of energy there. And you can optimize for any number of things. The thing that people most like to do is say which one gives me sort of the best return on my investment, right, given some constraints. There's a lot of things that go into this decision, right? It's not just, oh, let's try 100 kW, let's try 150 kW, whatever, right? We have to look at at different energy resources. A very common one is solar, right? Solar and battery storage often go in together, so they should be optimized together, right? The goal isn't optimize for solar or optimize for storage. It's give your customer the best system, holistic system that we can. So you have to take a holistic approach, a system level approach, right? This is what we're doing here. You can also do what we're calling rate class optimization, which is that I understand that you're on a certain rate class, a certain tariff today, general service 1, whatever your rate class is. But if you were to put in this battery storage system, it might be advantageous to switch you to a different rate class, let's say time of use, in which case you can take advantage of the ability for the batteries to charge and discharge each day, and you might be able to save some money there, right? So this is another factor in the optimization that we can play. Now, the starting point for all this is operational data. So the gold standard for this is actual meter readings taken periodically every 15 minutes or even more often of what the building used in terms of electricity. Okay. People often ask, if you don't have that, if you don't have these meter records, what can we do? And the answer is there's lots that we can do. We can use partial records. We can take records that are taken more infrequently. We can even go from past bills and build a model ourselves of what the building is probably doing in order to get this kind of data. So again, let's not let the perfect be the enemy of the good here. We'll use whatever data you have. Some data is better than no data, but even in the case of no data, it's important to have a conversation, because this is, again, the design phase. This is the start of the sales cycle and how you go about doing an energy storage project. Okay. So again, we talked a little bit about the design. Now in operations, right? It's important. The Keystone microgrid controller here, the Keystone EMS, is the thing that is the central point of control for the entire microgrid. It's very important to have the same company, the same people doing your prediction as doing your control, because otherwise there's going to be a disconnect. How can some third party make a prediction, financial or operational prediction, about a system that they then don't put into operation themselves? There's going to be completely different sets of assumptions, completely different operating theory, right? The two are going to be divorced from each other. And what you're going to run into is you're going to end up making a lot of promises to your customers based on the prediction that never get put into operation, right? And then there's going to be some hard explaining to do why the two don't agree. So that's really one big benefit, right? Is that if Fortress Power can provide all of the modeling and the control software for the microgrid, right, it just feeds this kind of virtuous cycle, right? We can understand your goals, we can understand your tariff, again, take a completely holistic look at the system, provide one piece of hardware integrated with the control software, and then we will do the operations as well. So let's take a little bit deeper look into the Keystone Designer features, right? Again, something that's made to be used during the planning stages of a project. Okay. So really, there's a lot of math that goes into this. This is a powerful optimization engine that looks at a lot of different what-if scenarios and helps you pick the one that meets your goals the best. It's not always a cut and dry decision. It's a really kind of counterintuitive thing. You might just think, oh yeah, give me the best system. But the best system here really is the one that meets your goals or your customer's goals the most closely, given all of your constraints. Right? The example I use is that some people say, well, maximize my rate of return, right, as a percentage. So give me the quickest payback you possibly can. Well, the quickest payback we can possibly give you is actually probably the smallest system we could possibly put in, because again, that gives me the highest amount of power relative to the amount of energy. It's very low upfront cost, and we can shave a little bit off those peaks and give you a high rate of return. But it might not be useful to power anything off-grid. So it would offer you essentially no resilience, and it might not even be a meaningful project. It might just be a very small battery system, right? So again, that's a really common thing that happens where people think, oh, I just want like the best rate of return. But that's not quite true if you dig into it, right? What they actually mean is I want the best rate of return given a project of at least a certain size to make it worthwhile, and I have all these resiliency goals because I want to be able to back up X, Y, and Z piece of equipment. Okay, so that's a collection of different goals, and that requires some real trade-offs. So we can run these what-if scenarios, we can make those trade-offs, right? With the data, knowing what we're kind of getting into. Right? So the output of the Keystone Designer really is a proposal, a project proposal. You should use this, right? The inputs are the data and your goals, right? Your building uses this energy today. You have these goals for your project, and the output is a proposal. You should use this size battery storage system, this much solar, this kind of control strategy, etc. Okay. So again, step one, we want to analyze the load data and look at DER, distributed energy resource sizing. Okay. So the gold standard again is 15-minute data. If you have that, that's great. If not, we'll work with you. We model the microgrid behavior using the this electric data overlaid, as well as the site's actual tariff. So we're not guessing, we're not hand waving this. We load the actual tariff data and we use it, in our analysis. There's no surprises. We can generate a financial pro forma automatically for each scenario, right? That's one of the outcomes. That's one of the things people always want to know is what are these cash flows going to look like? And we can calculate that out for each scenario. We will co-optimize, right? Optimize together the battery storage and the PV. It's not always the case that you just put as many panels as humanly possible onto a building. I know that's the approach of some companies. Some companies have great success with this. But if you do that blindly without looking at the data, you are leaving money on the table because it's not always the best system. Okay? There's lots to consider here. About site-specific things, all of which we can bake directly into the analysis. I touched on this briefly earlier. We can look at a rate class optimization as well. Once you put in all this solar and storage and other energy resources, maybe you could move to a different rate, a seasonal rate or a time of use rate or some other special tariff offered by the utility. We will use that utility's real data, right? So again, we're not estimating this. We're not guessing. We're not hoping that it's going to work out after the system goes in. We're going to calculate it. We're going to optimize it. And we can make a real recommendation, again, based on the ground truth situation. And finally, you can optimize for more than just money. Right? Here's an example from a customer that wanted to optimize for resilience. Right? So they had some TOU, some time of use rate, and they were concerned that if they used their whole battery system, that at the end of the, over the time of use period, that if there was some outage that happened, let's say right at the end of the time of use period, they would be stuck. They'd be in a bad situation because they just used their whole battery system. There's nothing left. So we ran a bunch of different scenarios for this customer, and we helped them optimize for their resilience given a budget rather than just rate of return here. So we can do a lot of these things. There's lots to consider here, right? We've been talking a lot about time of use, resilience, and peak shaving, but there's other things to consider here too. There's there's revenue available for grid services, utility, or other programs where you can charge and discharge your battery to help the grid, get paid some additional money. Another flavor of this is demand response, right? If the grid is under a lot of strain, you can discharge your battery, help the grid stay stable, and again, get some payment. So all of these things together, all these different applications together, we should consider them all, and the best system will again fall out of the analysis, given a kind of conversation with your customer. Great. And all of this good math is completely meaningless if you don't have a good way to present it. Right, so we can offer some we'll offer some reports so that you can sit down, show it, with nice colorful graphs, what the system's going to be doing, what your decisions are, what your trade-offs are. Okay. And finally, this part is very important. The output of the Keystone Designer becomes the input for the control system. And I touched on this earlier. This is very important because otherwise you have two different parties working in isolation. And if they don't talk, if they don't agree, if the design side doesn't feed the operations side, you have all of these cool predictions and fancy math has just been a big exercise. It's never going to see use in the real world where it matters. Okay? So the output of all this design exercise is not just to sell a system and walk away. It's to create a better control system in operation. Okay? That way you're not starting from zero with some fancy learning system that you have to bootstrap from nothing on day one. We've already done all your analysis. All right, so now we're ready to talk about operations. Okay? So we're going to go through a kind of tour of the Keystone system. I'll talk a little bit about it here, and then we'll go through and kind of click through a demo after this as well. Okay? So it starts with an overview of the system, right? You can see solar, power coming from solar, utility storage, any other generating assets you had on site. You can see it going to the load. You get some energy mix here. Okay. You can continue to drill down, right? So this is something that the operational, your operational folks might care a great deal about is how granular can I get? And the answer is very granular. So we're gonna go in increasing levels of detail here. All right, so there's going to be now this is sort of a more detailed screen that shows where is all the power going? Is it going to the utility? Is it going to charging or discharging batteries? What's the solar doing? What's the meter reading, right? There's a lot of different power flows to consider, and we try to consolidate that on one chart here so that you can kind of read it and look at it by color. You can use this to run some analysis here, right? So I can look at this graph and I can see that, oh yeah, so what is yellow? There's a lot of yellow. Yellow is the PV, total active power, right? So this is a pretty sunny day. We're doing a lot. We are utility rollback. So we're actually rolling the meter backwards quite a bit here in the middle of the day, right? Between 100 and 200 kW. This is a nice, bright, sunny day. Here later on in the day, once the sun went down, we can see that the battery starts to charge and discharge. Right, so this is a really nice overview of the operations for the key components of our microgrid right here. If you want to get even more granular, this is really helpful for troubleshooting also. You can go down to the individual equipment level and then even the individual data point level. So we are monitoring every Modbus data point that's available, right, on this system. So if you want to know, if there is a PV installation on site and panel level information is available, we can capture that. You can trend it over time and you can see, oh, panel 47 is outperforming panel 48 for whatever reason. We can go look at it, right? There's a record kept, a trend of every granular data point that you can get, and this is again really helpful for like the operational folks. Okay, so we have a alarming system here, and before I kind of go into this, I want to kind of make a distinction, right? We talked a little bit about what EMS is not. EMS is also not a work order management system. So the intent of this is not to be a work order management system. There's lots of great ones of those out there. You know, if you want to manage work orders, you should get a dedicated system for that. What we will do here is just give some visibility into the alarms, show what's going on, and then there's a way to acknowledge these alarms on the site, on the web portal here too. So if you want to just leave some notes or some maintenance notes for the future, and again, just say, hey, I'm an operations guy or a technician or whatnot, I'm acknowledging this alarm, I'm working on it. You can do it here on the portal. But again, you know, it's kind of not a fully featured work order management system. And then finally, reports. If there are other stakeholders in the organization that want access to this data, but maybe don't necessarily need to be able to log into the web portal and click around in real time, you can output a series of reports about the electrical operation and about the financial behavior of the site with, in different formats like Word and PDF. There's a bunch of different templates for the reporting. Again, you can see energy, you can see financial performance, you can see the maintenance schedule. And if you want something that isn't defined out of the box by us, there is a way to customize that export, right? So you can say, oh, I want a report that has this data point, this data point, this data point. You can do that too. You can set that up yourself. Okay. So next we will go and click around and do sort of a demo of the web portal so you can see these things in action. So next let's go through a quick demo of the web portal. After logging into the web portal, if you have more than one site available, then you'll see a list of all the sites that you have permission to see. It gives you just an overview of what it is, right? Name and alarm, some address, some information about the site and the current state of the site. If there's storage on site, it tells you what storage is doing, utility company, and whether or not there's a demand response program available in your area. Okay. Now this isn't available if you only have one site. You'll just be taken right to that site. And the important thing here is that this is hierarchical. They call multi-tenant, right? So if you are the CEO of the company, maybe you can see all of the sites that your company has ever done. If you are a district manager, you can see all the sites in your district, let's say. And then if you're a building manager, maybe you're only allowed to just see the site or the equipment that's at your building, right? We can split up the permissions in this way. Okay. Let's go ahead and get some more information about our demo site here. Okay. So we're taken to a kind of operational summary view here, right? And this gives you some information about what's going on here at site. So there is, all these different colors here. We kind of looked at a little bit this earlier, but there's a lot of information here. It shows you what is the solar doing, right? Oh, utility rollback is purple. Great. We can really see that we're selling power to the grid here. Battery discharging. So we're discharging the battery to keep the power in the building nice and low, right? You can see the utility consumption is real low. And then, back here we can see that the battery was charging mostly off of solar panel until the battery got nice and full. It gives you an overview also here of all of the equipment that's on site. This is all configurable too. So if you want different headline, if your operations folks want some, headline values that you're always kind of keeping an eye on, you don't want to have to click through, you can do that all here. If you want a reminder of what all this stuff is, PV, DER meter, PV1, all that stuff, then you can make an image. This is just a static image. This is not dynamically generated because for the most part, this equipment you install once and it doesn't change that frequently after that, right? You can get an operator, we call operator view. It's just a reminder of what's here so that were those things done in series, in parallel, where are they tied in? You can get an idea here. We found this is really useful. If you want to see what some of the alarms are, we can go in here and see these, right? So right now that there's like a rack over voltage alarm, you can see that it's unacknowledged here. Let's go ahead and try to bring this up. It takes a second, right? You can see if there was some history of this alarm, you could see it all here. Okay, I could acknowledge this with some note here if I wanted to as well. Let's keep going with this tour. So here's if you want even more detail than that operations view gives you, you can go into the analysis view, right? And here's where you can really dig deep. This is where the engineers and the real nerds love to click around. So you can see there's 761 data points available for this site. I just sort of picked 2 of them. I picked the frequency and the voltage of line 1 of the power. Right, it's kind of what you'd expect, right? There's the frequency, it's right, line 1 frequency, there it is, it's like bumping around 60 hertz, it's exactly what you'd expect. Line 1 voltage, it's going up and down right there around 280. Great, no surprises here. There's lots, you can go into any of these pieces of equipment and you can see any of the data points that are available, right? You can go in and pick any or all of these that you want, get some comparison of them over some date range, update the graph. Okay. This is sort of the sister page to the analysis page, the equipment page, because it lets you get a better feel for what's here, right? So here's some SunGrow battery storage rack, here's a SunGrow inverter, here's a utility meter, and it shows you all of the points that are here, right? So here's some Dynapower PV system. It shows you all the points that are available. If there's some that are buried in these menus that you find you come to frequently, you could pin that one if you want to. It gives you kind of the last known reading for all these. And if you were to click on one of these, it would send you back to the analysis page to give you, the trend of that over time. Finally, here at the control summary, this gives you a roll-up of what the control system is doing, right? And it gives you some metrics here. This is a time of use system, so it shows what's going on at the various on-peak, off-peak, super off-peak, right? It gives you the rate, and it shows you where's the power flows going, PV to load, PV utility, etc. up here, right? So this is, again, an overview of the control system in terms of energy. And if you want that in terms of revenue, I mean, it's similar because in this case, the kilowatts and the dollars are closely related, but you can get it, the information served to you in those terms as well. All right, and then we're back to the portfolio view here. So one more thing that we want to look at also is the report feature, right? So this is where you would go to get these reports. Again, delivered energy report. Financial performance, right? So again, in dollars, what does this mean to you? There's a site maintenance schedule. So this is configurable, right? If you want certain maintenance done daily, weekly, monthly, quarterly, whatever, you can get it done. You can get it here, send it to the person responsible for doing those tasks. And if you want to set up a custom report, you can, again, do that here. Just select the tags that you're interested in, select the date range, and then have the report exported. Okay. So finally, I saved this one for the end, even though this is often the first thing that people see, just because it's kind of the least information dense, but it is something that you will see quite often, right? Here's the overview screen for a single site. So it gives you some high-level information. We know that there's a lot more buried underneath here, right? So it's why I save it to the end, but we know that this is the roll-up information. We know there's a lot of details behind it, right? And it just shows you in broad strokes, power from utility, storage, solar, and here's what's going on right now. Okay. So I hope you enjoyed that tour of the Keystone Designer and the Keystone EMS. Happy to schedule a tour. If you have particular questions about your use case, you'd want to know how that would interact, please reach out, please let us know, and take care.